I would like to review the solutions for the pre-check for rational equations, section 4. You do need to be able to factor polynomials to be able to solve some of the problems later on in this section. So just a quick review. If I wanted to factor 2y squared plus 12y, that's a binomial with a common factor of 2y. Dividing each of those terms by 2y leaves a y plus 6. X squared minus 5x minus 50, that is a trinomial, and we need to find the two binomials whose FOIL gives us this trinomial. The first term factors as x times x. The factors of 50, actually of negative 50, whose sum is negative 5, would be 10 and 5. Different signs, and larger one needs to be negative. So x minus 10 times x plus 5. A squared minus 9 is the difference of two squares. So that is a product of conjugates, with the terms being what we have to square to get a squared and 9. So that would be a minus 3 times a plus 3. B squared minus 9b plus 20. A trinomial, the factors of b squared are b and b. The factors of 20, whose sum is negative 9, would be 4 and 5, with both of those being negative. So b minus 4 times b minus 5. Now going to identify the least common denominator of a set of fractions. Recall that the least common denominator is the smallest number that all of those denominators divide into. If it's not easily identifiable, there is a process to find it. If we have 7/18, 2/3, and 1/4, what we can do is factor each of the denominators. So if we factor 18, 18 is 2 times 9, or 2 times 3 times 3. 3 is obviously just 3 by itself. 4 is 2 times 2. And so the least common denominator has to be something that each of those divide into. So we need all of the factors from 18, 2 times 3 times 3. We need the factor of 3, which we already have, and then we need two factors of 2 for the 4 to go into it. We already have 1, 2, so we need one more. And so this is really 4 times 9, or 36. The LCD of x and 2x, which is really 2 times x, we need x to divide into it, so we need a factor of x. We need a factor of 2 and x for 2x to divide into it. We already have the x, so we need a 2 on that. So the LCD is 2x. For x plus 2 and x, notice that each of those are separate factors of themselves, right? And so when we build an LCD, we have to have each of those different factors represented. So we need the x plus 2 as a factor, and then the x. So x times x plus 2 would be the LCD of those two expressions. And in number 8, we have 3 divided by x minus 3, x divided by x plus 3, x minus 1 divided by x squared minus 9. So we begin by factoring the denominator that needs to be factored. So the x minus 3 can't be factored, x plus 3 can't be factored, but x squared minus 9 is a difference of two squares, so that is x minus 3 times x plus 3. So when we build the least common denominator with factors from each of those denominators, we need the x minus 3 as a factor. We need the x plus 3 as a factor. And then the third denominator consists of those two factors, which we already have included. So the LCD is a product x minus 3 times x plus 3. The second topic is to review the product of fractions. And number 9, 7/10 times 15/14. This is really just to review that fundamental property. Recall that you can divide out common factors from the numerator and denominator. So between 7 and 14, a 7 is common. Dividing 7 into 7 is 1. 7 into 14 leaves 2. Between 10 and 15, a 5 is common. 5 into 15 leaves 3. 5 into 10 leaves 2. So then we multiply the numerators and denominators to get 3/4. Number 10 is 2/7 times 7/2. This is really a product of reciprocals. The 7 is a common factor, leaving 1 when we divide the numerator and denominator by 7. 2 is also a common factor between the numerator and denominator, leaving a 1. So we have remaining 1 divided by 1, or simply 1. And that's true that anytime we multiply b over a times a over b, we get 1. The remaining problems will give you an idea of what you'll see when you actually go to solving rational equations, that is when you multiply an expression by an LCD. So if we have negative 6x times the fraction x minus 1 divided by 3x, we want to divide out the common factor first. So 3x goes into negative 6x, negative 2 times, and then we multiply negative 2 times x minus 1 to get negative 2x plus 1. 15a times 4a divided by 5. Notice that the 5 goes into 15 3 times, and so we have 3a times 4a, which is 12a squared. Five y times y minus 1 times y plus 4 divided by 5y. Notice that the 5y divides out. So we're left with y minus 1 times y plus 4. We have to multiply those two binomials to get y squared plus 4y minus y minus 4. So remember, I'm just doing the first, outer, inner, and last. Combining like terms gives us y squared plus 3y minus 4. And now we have 2 times x minus 1 times x plus 2 times the expression x plus 4 divided by 2 times x plus 2. So the factor of 2 is common and the factor of x plus 2 is common. That leaves x minus 1 times x plus 4, which is x squared plus 4x minus x minus 4, very similar to the previous problem, x squared plus 3x minus 4. To identify the values that make rational expressions undefined, we need to remember that a number divided by 0 is undefined. And so here we have to set the denominator equal to 0 to figure out what those restrictions are. In number 15, we have x minus 2 divided by x. To identify the restricted value, we set the denominator equal to 0, and so the restricted value is x equals 0. In number 16, y plus 2 divided by y minus 3. The restricted value comes from setting the denominator y minus 3 equal to 0. So we get y equals 3 is the restriction. In 17, 3u divided by u squared minus 4. So the restriction comes from setting u squared minus 4 equal to 0. And that's a quadratic equation. To solve it, we have to factor and set each factor to 0, or we could apply the square root property. But that gives us that u minus 2 is equal to 0, or u plus 2 is equal to 0. So the restrictions are that u is equal to 2, or u is equal to negative 2. In number 18, a plus 5 divided by a squared minus a minus 2. To find the restrictions, we set that trinomial equal to 0. Factoring a squared minus a minus 2, we get the factors of a squared are a and a. The factors of 2, whose difference is 1, would be 2 and 1. They have to be different signs, with the larger one being negative. So setting a minus 2 equal to 0 gives us a restriction of a equals 2, or a plus 1 is equal to 0 to give us a restriction of a is equal to negative 1.